creating and modifying constraints. This nugget is all about enforcing data integrity using constraints at various levels. There are two objectives in 70-464 that deal with data integrity. This one, which is just really focused on understanding the different kinds of constraints, how they work, and actually using them and building them. The second one, later on down the road in this course, we'll look at how to design for data integrity. So we'll kick this nugget off with an overview of constraints. We'll start with just a quick high-level overview to talk about those various levels of constraints and the things you need to think about. Things we'll cover more in detail when we get into our designing for data integrity. But we'll go over all the different kinds of constraints. Primary key, foreign key, unique, and check being the big ones that we're going to cover in this nugget. Then we will jump into the virtual nugget lab. We'll start with primary key and foreign key constraints and see how we can create them, some of the different options we can attach to them, like cascading and such when it comes to referential integrity. We'll also cover unique constraints, see how to use those. And at the end, we will cover how to work with check constraints at the single column level, at the multiple column level, which we call the table level, and then I'll even briefly mention there how to do cross-table check constraints. Let's start with an overview. So constraints help enforce data integrity. What is data integrity? It is ensuring that our data is consistent, accurate, and follows the rules that we want it to follow. And there's a couple of levels of data integrity. We have, for instance, something known as domain data integrity, which is really just column data integrity. And this could be anything from I want the data in this column to be these specific values, or I want it to fall within a range of values, or I want it to adhere to these rules, or I want it to be in this specific format. We also have something known as entity data integrity, and this is really row level data integrity. We're going to use this to enforce things like uniqueness and identification of our records. And finally, we have referential integrity, which ensures that the relationships between our tables are maintained. And a good example there would be a sales and product table. If we had a foreign key in our sales table referencing our products table, that would mean we couldn't enter a sale that didn't have a valid product in the products table. So that'll prevent the problem of orphaned records. So we've got a lot of constraints here to work with that'll help us enforce all these different levels of data integrity. The primary key constraint is there to enforce entity integrity. We need to ensure that we have a way to uniquely identify our rows, and that's why we use primary keys. Primary keys must be unique and not null. They can also involve multiple columns in what we would call a composite key. And then there's the idea of natural key versus surrogate key. A natural key is one that you can find in your existing data. So say you have a employee table and there's a social security number in there. That is going to uniquely identify a person, but the whole downside to that is social security, especially if they have dashes in their character field, is a wide key, and you want to try to avoid wide keys. So a lot of the times a surrogate key is going to be the better choice because an auto number field is about as good as it gets for performance. But if you can find a natural key that's small, then you wouldn't have to worry about an auto number, and it could make managing that table a little bit easier. But generally you're going to go with the surrogate key, which is creating your own field to uniquely identify the record. So primary keys enforce entity integrity. Check constraints enforce domain integrity. It allows us to do things like limit the acceptable values within a column, or ensuring that this column is within a range of values or a specific format, as I mentioned. And it works by creating what's known as a logical expression, which is just a Boolean expression. And if that expression evaluates to true, the data can come in. If it evaluates to false, it will be rejected. And we'll look at a couple of different ways to use check constraints at many levels, because again, you can do this at the single column level, the table level, which will use multiple columns, columns that rely on other columns, and then you can even do cross-table check constraints. Using user-defined functions, much like we did with computed columns earlier in this course. We can also use unique constraints to enforce domain integrity, and we can do this on a single column, or we can do it across multiple columns to ensure uniqueness at that level. Also note that if you do have nullability turned on, so you allow a null value, then you can only have one null value in that column. And a good example of a unique constraint would be like a social security number or a tax identifier, or something that only one person could ever have. Foreign keys help maintain referential data integrity. And so the idea here is that we create a foreign key on one column in a table that links to another column that must be a primary key or unique key. We're creating and establishing the solid link. So now if we were to do something in our primary key table, like say delete a record, and that record has a link to other records in our foreign key table, it's not going to be able to happen. By default, an error would get thrown because if we were to delete something in this table, then we would create orphaned records in this table. Now, there are ways around that, cascade options that we can put on, cascading rules to say if this deletes, then cascade and delete all the rows that were associated with this key. But by default, cascade is set to no action, which means it'll raise an error. We won't be able to do it. And we'll go over the other options when we get into the virtual nugget lab. But again, foreign keys just enforce referential integrity by establishing a link between our data. And it must be done on a primary key or unique column in the reference table. All right, let's head over to the virtual nugget lab. We'll start with primary key and foreign key constraints, and then we'll move into unique and check constraints. Here we are in the virtual nugget lab. So I've pre-launched SQL Server Management Studio. Let's bring it up. And I've added a new project here called 07.constraints to our solution. We're going to start here with key constraints, working with primary and foreign keys. And we're going to do this inside of our Nugget Demo DB, 3 tables here, learner, learner nugget activity, and learner nugget info. So how this works here is we have a learner, which just has a single primary key on it. No foreign keys on here at all. And then we have 2 tables that are going to reference our learner table. One is learner nugget activity and one is learner nugget info. Both of these have 2 keys. 2 foreign keys on them each. One references the learner table and one references the nugget table because we're tying learners and nuggets together. So we can't put a record inside of this table without a valid learner or a valid nugget. So the first thing we're going to do is drop our foreign keys. We have 4 of them, 2 in each table, which both reference, again, the learner and the nugget. And then each one of these tables also has a primary key. So let's first start by dropping all of our foreign keys. And then let's drop all of our primary keys across these tables. So we're good there. Now we should be able to refresh everything that we were just looking at, and there will be nothing there. Empty keys, and empty keys. All right, good to go. So right now we have poor data integrity because we can put anything we want into these tables. They don't rely on each other, and that would be tough. I would hate to be an application developer working with our database right about now. So now let's re-add our primary key constraints. Very simple, alter table, add constraint, name of the constraint, primary key, also make it a clustered if you want. If you didn't want to make it a clustered, you could remove that and still put a clustered index somewhere else in the table. And then what column we're specifying here as the primary key. So we're going to put it on our learner ID on our learner table. And notice here in our second table, our nugget learner info, we're actually going to do a composite key. One that is going to be learner and nugget. So we can uniquely identify this row by saying we can only have one record that is associated with a learner and a nugget at the same time. And then the last one on activity here is going to be on the activity ID. So let's highlight all of these primary keys, hit execute. That'll take a second to create because we have a lot of data in one of our tables, and it is creating clustered indexes. And if you remember, this last table, nugget activity, we have a good as our primary key, and we also put a clustered index, which is actually not good design. This would be a good one to just put a primary key on the activity ID and then maybe put an auto number field here for the clustered index. But at any rate, if we refresh our keys, we should have them all back. So now we can start creating foreign keys that link to these primary keys, link to our primary key on our learner table from both our nugget activity and nugget info table. And if we scroll down here, here's how we can work with foreign keys. So the first thing we're going to do is link our learner nugget info table with our learner table. So we're going to establish this relationship between the learner ID of our learner nugget info table and then the learner ID of our learner table. And it's simply alter table with check will actually check the existing data. You can also do it with no check, which will not check the existing data, but will check all data going forward. Then we're going to do an add constraint, name of the constraint. We're specifying our foreign key as the learner ID in our table here that we're altering, and it's going to reference the learner ID in our learner table. So that's kind of the default setup. Now I've got a couple of other options on here to deal with cascading. You can control that if updates happen inside of our reference table, our learner table, how are they going to affect the data here in our learner nugget info table, and same with delete. So we can control that if these actions happen on our reference table, what's going to happen to the existing data inside of this table. The default is no action, which is the highest form of referential integrity because it means if someone tries to update a key and we have data inside of our learner nugget info table that references and has a link to that key, that it's going to raise an error. So no action means no can do. There's also set null, which means if someone were to update a key in that learner table, but we have data inside of our learner nugget info table associated with that data, then we're just going to set it null in this table, which will create orphaned records, but at least we'll have a way to identifying them by looking at the null value. You can also do a set default. So if you have a default here on the learner ID column in your learner nugget info table, then it will get switched to that default whenever an updated value changed there in our reference table. And then cascade means it will update. So if we update a learner ID in our learner table, it will come over to the linked records in this table and update them to that new value. And you can set the same actions on delete. We're going to set this one to null. That way we can see this stuff in action. Then we're going to set up 3 more referential integrity linkages here, 3 more relationships. One that will reference the nugget ID from our learner nugget info in the nugget table, and then 2 that will reference learner nugget activity, 1 for learner and 1 for nugget. But notice here, this last one, we're going to do a with no check, which means it will not check the data. And if you did want to check the data later on, you could do it, or at any time, you can do an alter table check constraint with your check constraint name or any constraint name, and it will actually check to make sure all the data in that table complies. So let's highlight all this stuff here, hit execute, and we've got a problem, but don't worry, it's by design. I wanted to throw a curveball at you here. So it says we cannot create the foreign key with the set null referential action because one or more referencing columns are not nullable. Anybody know why? Because the learner ID column is not nullable here in our learner nugget info table. And if we look at this, see this, it's not null. And you know what? We can't make it null either because guess what? It's a part of the primary key. And if you remember one of the rules from our slides, primary keys cannot be null. So what's that mean? It means we can't do it. But we can do another action. And let's just do this one as cascade. So that way, if we delete a column now, or delete a learner, it's going to delete all that learner's nugget information as well. So let's just turn that to cascade, and now we should be able to create this constraint. All the other constraints were created successfully, just this one was not. So if we hit execute, we're good to go. And we can verify that by refreshing our keys on our learner nugget info. There they are. And also refreshing them here on our learner nugget activity, and there we are. So we've got all 4 keys, referential, foreign keys, back on our tables. All right, let's go test this stuff out. So we've got some insert statements down here, and let's just test it out. So the first one here, we're going to enter another record into learner nugget info, but we already have a record in there for learner ID 10, nugget 100. So this should fail on insert because we cannot insert a duplicate key into our learner nugget info table. So this is good. This is actually, we're violating the primary key here, not the foreign key. Again, because we have remember we have a dual key set up here on this table, a composite key across both of these, which must be unique, and it isn't. Now, what if we want to violate our referential integrity? We're going to insert one for learner ID 50,000. We have 10,000 learners, so the max key it goes up to right now is 10,000. So we're trying to put a record into our learner nugget info table that does not have a learner that exists in the learner table. And so this is going to tell us that we're violating our foreign key constraint against our learners table there. And finally, this one we're going to be okay on the learner side, but on the nugget side, we do not have nugget number 50,000. So this is going to violate the other foreign key that references our nuggets table. And that's a good thing to do when you're designing your database. Just make sure that you test out everything to make sure it functions as you designed it to do. So we tested out all of our keys, primary, both foreign key constraints, and we're good to go. Our learner nugget info table looks good. Now let's test out cascading actions here. And we know that we set an update action of no action, which means this should not work. This update should cause an error because we're going to violate, once again, that foreign key constraint because we do not have a learner ID in the learner table of 50,000. So if we'd execute, just to verify here, we are going to violate that foreign key. But we did allow cascading, the cascade option here on our delete statement. So first, let's just look at learner ID number 9999, see if we have some records. We do. We have 5 records out there for learner ID 999 inside of our learner nugget info table. But now if we delete that learner out of our learner table, it should cascade. Oh no, another error. I like throwing curveballs at you today. I'm keeping you on your toes. So anybody know here why we got an error? We didn't get an error from our learner nugget info table because we have a cascade option set up. But we have another foreign key from activity referencing that same table. So we're getting an error here on the learner nugget activity learners key. So what we need to do is either turn off cascading down here, or turn on cascading on the other keys that reference that primary key as well. And I'll show you the easy way to do this one. Let's go here into Learner Nugget Activity, into Design. We'll do this through the GUI. We want to go here into Relationships and Keys, and from here we can choose our learner, the first one, which I already chosen for us. But if we head down here into Insert and Update Specification, here's your actions. And look at that, no action, no action. So we can turn the delete action here to cascade, hit close, save it, choose yes, and now we should be able to run the same statement here, and this time it'll work in cascade through both tables, both Learner Nugget Activity and Learner Nugget Info. And to verify that here, let's just look at our Learner Nugget Info table. Well, Learner ID equals 9,999, and all of those records are gone. And then the same here would be for our Learner Nugget Activity table. Those records would also be gone. So that's how cascading works, and those are your options for setting it up. Just make sure, as you saw here, that if you have multiple tables referencing that primary key, that you're careful about it. All right, let's move on to unique and check constraints. So unique constraints are pretty straightforward, right? We just want to set up a unique constraint on something, on a column that we want to ensure is unique. And the other benefit to this is, of course, that we can create foreign keys that reference these unique constraints. So we're going to switch tables here, and this time we're going to work with our employee table. We created this employee table a few nuggets ago, and we're just going to keep this one simple so you can see how this stuff works. So we're going to do everything in one shot with this table. We're going to add a tax ID column and also specify that we want a unique constraint on it when we create it. So we'll say constraint, name of the constraint, followed by the unique keyword, which will give us a unique constraint. There we go, perfect. And you can see this actually by looking at your indexes, because it's just creating a unique index on that column. And now we can test it out by inserting a few records. This one will work because we have no data in there yet. All right, we're good. And then our second one will not work because we're trying to insert a new record with the same tax ID. So this will tell us that we're violating that unique key constraint. So that's about all there is to unique constraints. Just keep in mind that if you do have a nullable column like we do here, that you will be allowed one null for that column inside of that table. Let's move on to check constraints. And for here, again, we're going to use the employee table once again. This time, I'll show you a couple of levels here. We'll do one for format. We'll do one for allowed values. We'll do one for multiple columns that rely on each other and checking out a range of values. And then we'll test it all out. So let's start here with just a simple check constraint on a single column. And a good example here would be for checking format. Phone number, for instance. Let's add a phone number field to our employees table. And we're going to pop a constraint on it called ck_phone, check, and then our expression. So this is our Boolean expression. We're just ensuring that the phone here follows the format, digit, 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 space, digit, 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 dash, and then 4 more digits. So it's a good one to ensure that the format of the data going into the column is what you designed it to be. So let's do that. We'll add the check constraint. You can view the check constraints here underneath constraints. There it is. And now we can test it out. So let's update James Kirk's record here, which has an ID of 1, with an invalid phone number format. And that will tell us that we violated our phone check constraint. Now let's update it only this time with a valid format where we have our parentheses, which I also didn't mention here, parentheses, then 3 digits within them, space, 3 digits, dash, 4 digits. Looks good. And now we can verify that here. Let's just open the table, select the top 1,000 rows, and there it is. Looks good. So there's a good example of how to use a check constraint to enforce a specific format. How about a check constraint to ensure that only specific values go into a column? Well, here we're going to add a gender column to our employees table, and we'll put a constraint called ck_gender that does a check that ensures that gender falls within these values, male, female, or unknown. So let's highlight this, add that check constraint. We'll be able to see it here. We can also see our columns here looking good. And now we can test this out. Let's update again James Kirk's record here for a gender of Z. Obviously that's going to fail because it doesn't fall within one of those values. And if we update it then to an M, it should work. So check constraints are awesome. And I should point out, performance implications, you can actually increase performance through check constraints because the query optimizer uses check constraints to make better decisions. So keep that one in mind. Check constraints do not hurt performance. If anything, they can help performance. The only way they'll hurt performance is if you have an insane amount of logic in your check constraint that's doing something crazy, or cross-table check constraints can also decrease performance if you have a complex UDF and you're doing lookups and things like that. But generally, they can certainly help to increase performance. Now, the last one I want to show you here is a table level check constraint. So this time we're going to create a check add some columns, start and end date, and then we will add our check constraint after these columns are already created. So let's do that. And now let's add a constraint that's going to check to ensure that the end date is always greater than the start date. So this is, again, called a table level check constraint because we have columns that are working together to do the check. So let's do that. Let's add that check constraint. And now we can test it. So this one's going to fail the first insert because our start date is after our end date, or I should say our end date is before our start date. And we need to ensure here that our end date is after our start date. So this will fail, and it'll just tell us that we violated that check constraint. And then this one will succeed because our start date is before our end date. There it is. One more thing that's really good to know here, and I did mention this in the previous script, but I just want to go over it here so you can actually see it in action, is disabling and re-enabling your constraints. So we can do an alter table, name of the table, no check constraint, followed by the name of the constraint, and that will turn off the constraint. And now we can do things like enter invalid data. So now we can update a record here and set the gender equal to Z, which is obviously invalid. And now we can turn that constraint back on. And now if we try that again, this time it will fail. There it is. So that's really useful to know in case you do want to load up some data that is invalid, but you still need it. Then you can turn your constraints off. Popular thing to do. And then finally here, if you need to drop constraints, it's as simple as alter table, table name, drop constraint, constraint name. So let's drop all those constraints we were just working with. And now if we refresh our constraints, they're gone. In the CBT Nugget, we learned how to create and modify constraints. We started off with an overview where we got familiar with the different levels of data integrity, domain, entity, and referential integrity. And then we focused on the 4 big constraints that were required for this objective, which are going to be primary and foreign key constraints, unique constraints, and check constraints. Then we jumped into the virtual Nugget lab. We got familiar with how to work with primary and foreign key constraints. We saw how to use a unique constraint. And at the end here, we saw the many ways to use check constraints. I hope this has been informative for you, and I'd like to thank you for viewing.